Okay, so welcome everybody to day one of SRE, Site Reliability Engineering and Cloud Performance Engineering and DevOps course, friends. So in the last session, friends, we had the demo on Wednesday, uh, IST time zone, right? We had this demo and today is the day one. So we're going to start our course today. Before we get started, there were a few questions which I think we might have missed to answer. We will take up the questions first. I'll walk you through how we are going to go about this course, the flow of topics that we will have, in what depth we cover. I'm going to just walk you through, and then we'll take up the questions. And then, so the second half plan is to utilize the second half of this session is on the start the day one. We'll actually start the day one. Okay, so that's the plan, friends. So as mentioned in the last session, friends, this is the course that we have, and we are going to talk about these topics. We will talk about cloud, AWS. I get this question that why not Azure, GCP? See, we cannot, first of all, we cannot accommodate all the cloud providers. But having said this, it doesn't mean that if you know one, right? Let's say you know one. Let's say today you don't know any cloud. How do we work, operate, and manage? And you learn AWS. So it's easy to pick other cloud providers, whatever you're working on or your company is working on. It could be Azure, it could be GCP, it could be OCP, Oracle Cloud, right? OCI, they call it, Oracle Cloud Infrastructure. It could be anything, friends. So the point here is that if you know one cloud, the use case remains the same. Why do we use cloud, by the way? Because we want to get the infrastructure, we want to get the server, right? We want to get the storage, we want to manage our users, we need to get the databases, right? So we need these things. So these things are common for every cloud. Okay, the use case of using cloud is common. Let's say, for example, if you are a performance testing background, so let's say you know LoadRunner, let's say, and you want to start on Jmeter. It's a very two different tools, but they serve the same purpose. So you can easily understand how it works. You will record the script session. If it's API based, you will ask for the curl, right? You will have some parameterization, correlations, right? You will simulate some load. You know, the look and feel will be different, but the use case would remain the same. That's the point. So I get this question often, so I just thought to make this clear, friends. So if you know one cloud, it's easy to pick other cloud. That's how I learned. Today I have worked upon 4 cloud. It doesn't mean that somebody has taught me, right? No, I started with one, explored one in detail, and then when I learned one, it was very easy for me to work on any other cloud. Just the look and feel will change, the UI will change, the name will change, right? That's it. The use case remains the same. Why are we using AWS or why are we using Azure? The use case is the same. So we will talk about AWS in this course, friends. The first thing when you enroll, right, the first thing that we give you is this Linux recorded session. It's going to be my recorded session. I give you this. How it looks like, very simple, easy to understand, 3.5 hours of recorded session I provide. Earlier used to take this live session, but I just want to manage that time well so that we complete the batch in 3 months. If not, it will go further, friends. So we give this. The first thing that we do is provide this playlist. And it's very simple, right? 3.5 hours of the session and purely from scratch. And if you just go over this, you are sorted on the Linux part. How do your understanding of Linux is going to be very simple. I believe in the tagline that get as comfortable as you are with Windows, get as comfortable with Linux. That's what my tagline is. And that's what I believe in. It's just an OS, nothing else. It's just that we have not got the exposure. That's the only problem, right? We have not got the exposure. How do we work on it? That's the only thing I see as a challenge. But apart from this, friends, it's going to be very simple. So we'll make this simple. So that's what we're going to do. The first thing, and you will be and we'll be making sure you have the platform to perform, to execute commands. And we will do that through EC2 instance, we will in AWS, we have a service called EC2, Elastic Compute Cloud. We use this service to get a server, right? We will make sure that you know how to create the server, do SSH to the server. Again, you would say, what is SSH? Most of you may not know that SSH is a protocol. We connect to the Linux server, right, remotely, because that's what we do in the cloud. So if I just tell you what SSH, what we do, friends. So this is what we do. So see, cloud is a data center, not right. It's in somewhere. We have multiple data centers across the globe. AWS has 120 data centers across the globe. So we create server in their data center. Let's say their cloud is this, right? AWS cloud. We will create a server there. In their cloud, in their data center, we'll create a server. But we need to log in, right? If you don't log in, then how we would be able to do something? How can we install something? So we are somewhere outside the cloud network, right? I am outside. So we will create the server and we'll try to log into this. And this process of connecting to the Linux server is we do through SSH protocol. If it's a Linux server, SSH protocol, we call it secured shell, SSH. If it's a Linux server, if it is Windows server, anybody knows about this? If it's a Windows server, which protocol we connect, friends? Anybody? Let's say my server is Windows server. Go ahead.
It's V9.
V9. No, that protocol, is that V9 a protocol? Dinesh, please check that. It's RDP protocol, remote desktop protocol. So if it's a Windows, RDP, if it's a Linux, SSH. So depending on the operating system, the way you connect to the server is different. So we're going to make sure that you're comfortable in creating a Linux server or Windows server in the cloud, somewhere in the cloud, and we will not pay for it. Every cloud offers a free tier. We will leverage that. I'm going to guide you how do we create the account in AWS. Similarly, you can create the account in Azure and GCP. All provides free tier, but I would advise you to focus on only one cloud. Later, you can do that for Azure and GCP as well. We're going to make sure it's we don't incur cost, and you can get the server and you practice Linux. So we'll start with the Linux server and you practice Linux server. That's the plan, right? And that's how we will take this up. And this AWS is going to take it, friends, quite some, because we meet 3 days a week, mostly Monday, Wednesday, and Friday. It could change. Let's say if I have a meeting on any of the day, if I'm not available by some region, I'll compensate that in other weekdays itself. Okay, so please be available. Mostly 90% we'll have on Monday, Wednesday, and Friday. If we could not, we'll meet on Tuesday or Thursday, any one day. 3 days a week we'll meet. And we take it, friends, quite extensively. This 15 hours we meet, we discuss in detail, friends. In detail we cover, because that's the fundamental ones. And the way we cover is different. We cover from the reliability perspective. We cover from the performance perspective. We cover from the high availability perspective. We cover from the cost optimization security perspective. So in any architecture, right, when any software architecture design the solution, right, they need to compliant with these. They should meet these criteria. The application has to be highly available. If it's not available, no good, right? The application has to be highly performing, performance-wise. Secure, very important. Security, reliability. The failures will happen, but how soon you recover, and with the cost optimized solution. So we are going to discuss the cloud in a very different aspect, which is required for the SRE engineers. The mindset, how we should look at the service. EC2, simple service. It give the server, but there are so many things we do on these aspects, and we'll touch base on each of these things for every service that we cover. And we cover approximately 15 to 20 services in cloud itself. And we talk about, for all the services we talk about in these things, we talk about high availability. How are you make sure your application, let's say Flipkart, Make My Trip, is highly available. Performance wise, there are services. See, I'm not talking about the code optimization here. Okay. So understand this. The performance part, when I say, I'm not talking about code optimization. Code optimization can come here, right? When I say from the cloud perspective, code optimization, I'm talking from the infrastructure perspective. Let's say you are getting a database and the database is having high IO. What would you do? What would you do from the cloud infrastructure perspective? If infrastructure is not good, how much ever you optimize the code, the performance is not going to be improved, right? So we need to tackle the performance at every layer: infrastructure layer, code layer, network latency layer, database layer. We will touch base on everything, friends. So that's the mindset. So the way we could talk about it touch base on everything for all the services. Okay. Once this is done, friends, it's going to take some time, and we will talk about the microservice architecture. Again, the containers. We will talk about VMs here. In the cloud, EC2 gives us the virtual machine. We deploy our application in the virtual machine. But that's not how things are working now, right? We are deploying on the containers. Why are we doing it? Cost optimization. Because in containers, we can optimize the resources of the VM efficiently. It has been observed that the VMs are not utilized fully, 20–40% utilized. So what we do the containerization. We install a container engine like Docker in the virtual machine, and then we containerize it, and we deploy the applications, microservices in the container. So again, I'm not going to go in detail, but we cover at a level, friends, that it is good for a DevOps engineer, SRE professionals, cloud performance engineers, anybody taking up this role, right? All the three profiles, right? We cover. Anybody who would looking forward to upskill themselves in any of these careers, we cover up to that level till ingress level. If you know about ingress, HPA, horizontal pod auto scaling, vertical auto scaling, or vertical like the cluster auto scaling, if you have just heard of these terms, we cover up to that level. Again, if you want to know in detail, I just don't want to just go over the topics, since it will be overwhelming. Just know that we're going to cover in detail on the cloud part. Everything, whatever listed, we're going to cover. Linux part, recordization, everything would be covered. The architecture part, microservices, and now the Docker is this much we cover, and the Kubernetes we cover this much, right? Till ingress, and we use the managed service. Everything is hands-on. I'm going to create cluster. I'm going to deploy applications, full-fledged applications. If I talk about data Docker, I'm going to install a web application, WordPress application, databases in that, how they communicate, everything, right? Full-fledged application, how you. So that's what we do. Complete hands-on, right? With understanding. HPA, very important from the performance perspective. How pods auto scale based on when the load increases, how it auto scales. And that's what every company does, right? Every company is using cloud. And in the cloud, it's very important to auto scale, because see, that's the fundamental difference, right? On-prem and cloud, what is the difference? In on-prem, friends, we purchase all the servers. We procure, we purchase. Now, when you have purchased, whether you auto scale or you don't auto scale, you are paying, you've already paid already. You have paid already while procuring. But in the cloud, it doesn't work that way. We pay as we use. If we use more, we pay more. So it becomes very indispensable, very important, critical in the cloud that we auto scale. Right? Do we all agree on this part? Everybody has any difference of opinion that it's very critical in the cloud to auto scale? We will talk about that, friends, why it is required. We have a from the VM perspective also. If you talk from the cloud, we talk from the VM perspective also, auto scaling from the VM, and from the container perspective also we talk about auto scaling. So both perspective we talk about auto scaling, friends. So very important. Once that is done, friends, we'll talk about DevOps. Very important to understand how performance engineering fits in DevOps, right? We talk about DevOps. We talk about automation here. It's all about automation. DevOps is all about automation. We were perfectly fine in Agile. There is no process, but the manual process has slowed down the process. When the code is ready, I would like to take my code to production. But if we do things manually, It takes a lot of time. So we need to automate every process. Once the code is ready, why can't we automate to deploy the code? To build the, let's say if it's a Java based code, why can't I use some Maven build tool, Maven Gradle, these tools to build the, the code, right? We get the jar file, war file, deploy that in the QA environment and have automated script to do the functional testing. Once functional testing is done, have the automated script, Jmeter script, LoadRunner script to do the performance testing, security testing, UAT testing. And when every test passes, why can't we again automate to deploy that code to prod environment? That is what DevOps focuses on. Where all we could bring in automation in this process so that we can reduce the time it takes to deploy the code when it was already ready, right? Sometime back. That's what DevOps focuses on. And we will focus on this. How do we create CI/CD pipeline? How do we automate the process from the Jenkins perspective? We'll take about Jenkins. We'll talk about Jmeter integration, right? I'm going to show you the pipeline. I'm going to install Jenkins, create jobs, and we talk about Jenkins file, friends. That's the pipeline as code, Jenkins file. We talk about Maven here, right? Uh, Once that is done, friends, we talk about databases. See, you using database. Let's say I don't know what is the setup of your current database. Somebody is installing it, or you have a DBA, dedicated DBA in your team, right? Or DevOps engineer doing it. But cloud is here to make things simple. Cloud has automated most of the stuff. Today, if I need to create a database, let's say I need to install Oracle database or SQL Server, Microsoft SQL Server database, I just need 10 minutes and my database will be ready, right? I don't need to worry about high availability. If I can set up two database, primary and standby. If primary is down, standby would be functional. If load is more, read calls are happening to the database, I can create read replicas and everything is automated. With just a click of an option button, we can use that, friends. Because we will stick to the cloud, friends. If I just show you, see, cloud, how much ever AI comes, friends, cloud has been with us, right? Because cloud is helping to automate further. Cloud has always helped in automated things. There are a lot of roles which were existed 10 years back, Linux, admin, system, admin, they have all migrated to DevOps. DBA, there are no such DBA role, just barring the few big companies where they have a dedicated big clusters. Because cloud has everything in it. If I talk about database, cloud has these many options. If you need relational database, get it. If you need Mongo database, get it. If you need Cassandra key space, if you need in-memory database like Redis and Hazelcast, you might have heard of. Elastic Cache, we have it. MemoryDB, in-memory database. Oracle database, you can use your on-premise license and bring your database, create a database here and use the same license. So we have so many options, all are managed database. So we'll talk about these databases. We talk about observability using Prometheus, Grafana, Elastic Stack, along with CloudWatch. See, CloudWatch is the AWS. With every service, you will see me talking about CloudWatch. So that's what I have not listed separately here. CloudWatch is because if you create EC2 instance, you will have CloudWatch showing all the metrics, right? So we talk about, apart from the CloudWatch and Linux monitoring, which I will talk about in this Linux, how if you don't have any tools, how can you use Linux stop command or free command or df command or sar command to write a shell script to capture CPU memory of the host? We talk about that also in the observability. I have not listed here. It will be listed in the website. Let me check it. Yes, we have it. So CloudWatch, Linux monitoring, Prometheus Graph, and Elastic Stack we talk about. For the troubleshooting perspective for the Java applications, we talk about Java performance engineering. That again, this is going to be a recorded session, my recorded session itself. Again, just to manage the time, go over it. And I don't give this upfront because I don't want you to be, I want you to be focused on till Kubernetes. I don't share this. Okay, because very vast things, okay? And I need you to focus on, do the hands-on. I need everybody, friends, enroll only when you are dedicated to spend at least 1 hour, okay? Apart from the time, if you just attend it, right? And that's why we are meeting alternate days so that you have time. And that's when you will make the best out of this course. And your skill level will be at a different level in 3 months. If you do this regularly, every day, 1 hour, friends, spend time after the session, practice it, come up with the questions, we'll take up your questions, and that's how you will grow. Your technical skills will be growing. It will make a huge difference in 4 months. I have been getting messages from various people, those who have learners, those who have attended my course, that this course is helping them. This only thing you have to, well, you will forget things. Today you will like it. Okay, wow, things are so simple. But if you don't practice it, don't spend some time, you will forget it after a month. That's the problem I see. So don't do that. Please have dedicated time, commit it, friends, at least an hour to make the best out of this course. And I can promise you that your level, your technical level will be a different level in 4 months, right? Okay, so we talk about Java performance engineering, as I told you, one of the recorded session, my recorded session itself. We talk about automation, Terraform and Ansible. We talk about SRE concepts. We talk about reliability in AWS. How? So reliability is a very important word. Site reliability we call. What is reliability? See, failures will happen. How much ever you try, even Google, Amazon had a downtime. Failures will happen. But how soon you recover? That's reliability of the application. And that's very important thing. So whenever you design a solution, you have to make sure through chaos testing, right? Okay, how about my reliability? What if my load balancer goes down? What if my this server goes down? Is my application going to be down? We need to test this, and that's all. That's chaos. You create chaos to the system. So we need to discuss reliability is the most important term, right? And the plan. What will you do? That's why we have various different perspectives. So we need to approach this topic to a, if you don't have the fundamental knowledge on the Kubernetes and the cloud, friends, that's the most vast topic that we cover. Most vast topic, the cloud and the Kubernetes. If you don't have that understanding, right, you would not be able to relate if I just whatever I say, right? So you need to understand availability zone. Why do we deploy multiple node per AZ? We should leverage multi-region disaster recovery. How do we do disaster recovery? How do we back up your databases? How often should we back up? So we need to discuss so many things, right? And that's what will give you the exposure and the mindset. Okay, this is how we should approach the high availability or reliability, right? And then once we have the fundamental knowledge, friends, we can apply this. We should use the Gen AI tools. Once we have the knowledge, right, we should be leveraging the tools, uh, leveraging the Copilot, Chat GPT, the normal, explore things. One thing, friends, the most critical, right, I would say, is the troubleshooting part. That is where we need to improve on. I see most of the performance engineers, DevOps engineers, they lack the skill. This skill, no AI can replace. Understand this. This is my view. If you know how to troubleshoot an application, an issue, performance issue, or any issue, right? How to go about it, how we should approach this. That is no AI tools can do this automation part, this troubleshooting part. Everything, if it's a straightforward automation, let's say Selenium. If you have a test case, Selenium can automate it. They know what function to write. They know that it's a very simple task for any AI tools, right? Gen AI tools to automate that. But how about troubleshooting? Your troubleshooting depends on your problem, your specific problem, your application problem. It depends on your architecture. It depends on where is the contention. So how can a Gen AI tools can do this, right? And that is where the SRE professionals, the performance professionals, performance engineering professionals, the DevOps professionals who are looking into becoming SRE, that is where these AI tools can never replace you. And we should leverage these things. Let's say today, Let's just give you an example. Let's say I have learned this. Let's say there are so many databases, right? Let's say I don't know about Cassandra database. I'm just giving you one example. Or if I don't know about Redis, how Redis works. Or let's say I don't know about Kafka. Or let's say I don't know about SQS. Let's say I don't know. But if you know it's a database, it's a NoSQL databases. Why do we use it, right? You can explore things. We should use the GenAI tools to understand the problem, performance problem, common problems. I'm going to walk you through how do we go about the thought process. Let's say you don't know because you have worked on, let's say you have worked on Oracle, you have worked on MongoDB. Let's say you have worked on these two databases, but in your architecture you are joining the company, but they're using Cassandra and you don't have any clue. How do you get started? So should I learn Cassandra from scratch? No, we should understand what is difference. For databases, the read and writes matter. How the read happens, what is the process involved in the read operation and the write operation. That's when the database are differentiated. You have a concept of tombstones, right? Whenever data gets read and write, so you have this concept. You need to know the basic understanding, check for performance problem, common performance problem, what you are facing. So we need to use these things. Even if I don't know, let's say there are so many databases, I have not worked on all, but if I see, okay, this is the database they're using, and I'm seeing there could be a problem, but I don't know how to go about it, how architecture of database, but I know the database in general functionality. I can explore in 15-20 minutes. I can give you a suggestion, do this, even if I don't know the database. That is where the AI tools are going to help us. Help us, performance engineers, help us, SRE engineers, help us, DevOps engineers. That is where it's going to help us. We should know how to, what to ask. But if you do not know, if you have not worked on any of the database, how, if you don't know how the functionality of database works, we cannot, even if I give you anything, you would not be able to come up with the right answer. You should know how the Kafka asynchronous things work. Kafka, why do we use Kafka? Once you know that, you can explore this. What is the partition concept, consumers concept? So friends, we should have the fundamental knowledge, have that mindset of troubleshooting. So focus always on the troubleshooting. We need to upskill our troubleshooting experience, and no AI can replace that, because that's very much specific to your application, to your architecture, your user load, your pattern. How much ever they can try, they can automate the dashboard, they can create the alerts, simplify the alerts creation. All those things could be done. But the troubleshooting part is going to be very much unique, friends, and we should leverage the AI tools to make things simple, right? So that is the approach we're going to talk about, friends, in this course. Um, that's the understanding, friends, right? And I'm going to share all the documents with you. I'm going to share once you enroll. I'm going to share this Google Drive with you, and it has all the PPTs that we talk about from the cloud perspective. We cover in details of it. You're going to find 150 slides here, and that's just for the reference, right? You will see we're talking about all these things. So it's the cloud part, very in detail we cover, friends. We have the Linux part, the you will see the how we, and that's the same PPT I have used in the recording, right? That's how. So from the cell, what is a cell? What is a different kind of cell we have, and directory navigations, man command, all the commands that we have gone over, right? In the recorded session, same thing, the same thing. We have the Docker, the Docker part, the container engine part, and this is the Kubernetes part. It's the orchestration. It's the Kubernetes. So from the architecture of Kubernetes, how Kubernetes is architected until it's auto scaling, right? Again, very deep. We are very in detail. We cover till ingress, how HPA works, what are the importance of these resources in the YAML, right? How the ingress works, HPA, the horizontal pod auto scaling, how it works. So it's going to be hands-on. friends. I'm going to show you auto scale. You will see pods scaling up. You will see VMs. If I cluster autoscaler, you will see the VMs getting scaled up. You will see things, right? And that's when you will understand, okay, this is how it works, right? Again, for the Docker part, container engine, how do we create containers? We talk about that. So container and Kubernetes is a very vast topic we cover, right? It's very important topic. Once that is done, friends, we have a lot of SRE concepts, right? We talk about databases, we have got multiple databases in AWS. We have got various use cases of databases. So many databases we have in AWS. Why do we use a database? How do you achieve high availability? How do you achieve read replicas for the performance side from the infrastructure perspective? See, SQL tuning, we are not going to talk about it. So understand this, right? We are not going to talk about SQL tuning. We are not going to talk about the code optimization, right? It's from the infrastructure. Yeah, Java performance engineering will help you understand the code, but we are not talking about data structures to optimize the code, right? We are talking from the infrastructure, from the platform perspective, from the cloud perspective, what to do to make things better, right? SQL tuning is, yes, indexing, SQL tuning. It's a SQL tuning topics. We are not going to talk about those in database. I just want to be clear, friends. So that we are on the same page. We are going to talk from the cloud perspective, from the infrastructure platform perspective. How do we handle things? We talk about performance engineering, friends. We talk about how memory management works, right? Various GC algorithm that we have, right? This is going to be the recorded session, as I told you. Various GC algorithm, how the various JVMs are there, how we work on the parallel GC, how GC works in parallel GC, various attributes that we use in CMS, how it works in G1 GC, how it works. We talk about GC log analysis, heap dump analysis, thread dump analysis, right? We talk about these things, friends, in the Java performance engineering. We share a lot of books for you to explore this. Java performance books. It will help you troubleshoot mindset, right? Anyway, I'm going to walk you through how do we go about troubleshooting any application, right? Uh, but these are for the Java perform. If your application is Java based, this is the gold mine, right? That we need to understand these things, how these things work, how GC works, right? And very useful documentations, the books, right? And we have it, and it will help you understand the process, right? Friends, so that's all I wanted to cover in the first half. I'm going to give you a walkthrough. We're going to be cover the automation part, eliminating toil. I'm going to share Python scripting, some common Python scripting use cases that we have, friends, so that you understand. If I share you 10, 20 use cases of Python, friends, and that's all, you can tell this, okay, you have been using this automation, you have already applied these, you have the code with you. You have the code with you, right? You know how to use these things, right? You have the code with you and you can use these things. These Python scripts, you have used it for these many purposes, right? So if you just see this, I'm sharing this code. How do you do sorting files in a directory, right? So Python code which can do this. Again, Python code to automate the renaming multiple files. So just small functions which will help you very much in the interview process, in making, in convincing someone that you have worked on Python, you have done on automation, friends. So that's all on the first part. Apart from this, we share the Java performance, the, the programming language, the Python and the Java. You can pick any one of those two, but we share both as part of the course, friends. This is not my recorded session, so please be aware. Whatever I told is going to be whatever I've listed here is going to be my recorded session. Apart from that, we provide Java and Python programming. Somebody very good at, competent at Isha Trainings we have collaborated with that, and we are sharing as part of. So you don't need to go anywhere. Just this course is enough, right? We have complete thing here. Okay, friends. So that's all. Any questions before I start our day one agenda, friends? All good? No questions? Silence means no questions. Okay, I hope everybody.
Hi,
Go ahead.
hi, Roshan.
Yes, yes,
Yeah,
go ahead.
I have one question. Like, I'm doing performance testing for
Hmm,
last 3 years,
hmm,
like not engineering, and that too in on-premise,
hmm.
not in cloud. So here I see like it's basically like, as you said, it's SRE, DevOps. It will help, but for me, I'm not sure because for us, we'll test the application, and also I don't know performance engineering, so I'm a little bit confused, like how it will help me. Still, I'm not because I
Okay.
can use the observability. Maybe it
Hmm,
will help me,
hmm.
and if the application is in Java, then I can leverage the Java performance engineering.
Right.
So this two, I feel like it will help me, and also the cloud, because anyways I will learn cloud. So these three, I think, like I can leverage, but
Okay.
others I'm not sure how to
Hmm.
leverage. So like, can you explain? Like,
Sure.
can it?
I'll ask a couple of questions to you. I'll ask a couple
Mhm,
of questions, right?
mhm.
You, as you told, you're working on premise.
Yeah.
Do you see yourself working in on premise after 2 to 3 years,
No,
or in
no.
future,
Yeah,
right?
not sure. Yeah, yeah, for
Right.
sure.
So
Yeah, yeah.
that solves your cloud part, right? And how
Yeah,
do we go about it now?
yeah.
You right now, if I ask you if your application is deployed in the VM,
Yes.
right? Do you think it's gonna be the same and you are not gonna use containers in future,
No, no, they are also using containers,
right?
but it's like we test, so it doesn't matter whether it is in container or not. Like we
Okay.
just do some monitorings. Yeah.
Okay. So how so you don't do capacity planning basically?
Yes, yes, we are not doing that.
So that's one of the very important skill in the cloud, right? Because we have to do capacity planning, we have to do auto scaling. Do you use Kubernetes as well right now in your architecture?
It's there, but we are like that the way you said, right? We are not doing capacity planning. So are we like, will I be able to get that?
Absolutely. That is what the
Okay.
see. I'll tell you.
Mhm.
Just think. Let's think rationally. What is the performance engineer does? Performance engineer simulate the prod load. Try to simulate the prod load depending on the infrastructure in low environment, and then they say, okay, we have tested 25% of the load of prod or 100% of the load, and it is good, going good. So if we provision the same infrastructure in prod, we are good. And let's have 20% buffer also. Correct? That's what we do.
Mhm.
We just don't test the application, and if we don't know the infrastructure in prod and the load in prod, then we cannot justify. We simply don't want to put the load and test for any load, random load, right? It doesn't make any sense. If you think rationally, you would understand performance engineers are there to suggest the production based on the production load. They simulate some load 50%, 25, depending on the infra. If you have enough infra, simulate 100%. And we say, okay, if this many load comes, if this load comes into production, your system will be able to handle those many requests. But if it increases, have buffer, have auto scaling also configured, because we don't know, right? If any sale comes, what would be the capacity? Let's say Hotstar, let's say right now in Sony Live match is coming, or in Hotstar IPL matches gets during the Hotstar or during the IPL match, they have so many connections. We stream, so many people start to use it. So do you think the infrastructure requirement in during the match and during the and normal load going to be much different, right? I hope you understand
Yeah,
this part,
yeah, yeah,
right?
yeah.
So who would suggest that? Who in the company can suggest that? Only
Yeah.
one team, only one person can suggest that is the performance engineer, because they are simulating the prod load. They are doing auto scaling. If not performance engineer, then who? Who simulate prod load? So if we are not doing that part, right, we should try to think. You should ask your team member or you in your own company, why are we not doing it? What is the prod load? Why are we just doing a random load test and just certifying our application? That's good. I'm not saying it's not a good testing. Yes, you're certifying the load, your application, that, okay, the last time when this code was run with this load, this was the response time, this was the error. Now they have changed something in the code base. I'm going to run the same load test. I'm going to check how things are, whether the API or transactions have degraded or not, or are we observing any error code or not, right? So good test. But the eventual part is the capacity planning and the auto scaling in the cloud. And that is what you will get exposure on. In the cloud, the way we talk about auto scaling of VMs as well as auto scaling of Kubernetes. I tell everybody, right? I suggest everybody, whether you join this course or you don't join, you should try to be in the cloud domain. You should be in the Kubernetes domain. If you please join there, because that's the future. That's how things will be. If you are not doing capacity planning, if you don't have the understanding of Kubernetes, do something to get there, because eventually you will be forced, because every company is doing this migration from VM to Kubernetes to containers, right? And we have to test auto scaling in containers, right? So that is what you would get exposure here. um, I hope I answered your question.
Yeah. Yeah. Thanks, Roshan.
Sure. Anybody else? Okay, friends. We're going to start the day one, friends. I start our day one with a very simple topic, friends, and ask this very simple question. If you would have attended one of my workshops recently, then you might answer this question. I would have covered this here. What is cloud, friends? Why are we talking about cloud? Why this cloud? And when we say cloud, we have to compare with on-premise. Anybody would like to go ahead? Why cloud? How do I define cloud, and how do I differentiate cloud with on-premise?
So I can tell,
Go ahead.
Ocean, yeah. Cloud is the one where we can do the scalability and making sure that we can have the availability as well if we use the services of the managed services of the cloud as well. But when it comes to the on-premise, to procure the infrastructure, it will be taking months and months, then it is going to be tough also. But if you procure the same infra in the cloud, we can get it done in a matter of minutes, and we can start leveraging the products for the products as well.
Right.
That's
Very
what
good.
my
Yeah, that's
understanding.
that's correct. That's correct. Correct way of thinking it. Yeah, I'm
Yeah.
looking from the definition perspective, from the name. What is cloud? So when you say cloud, what comes to our mind? Infrastructure. What comes to our mind?
Uh, yeah, it's easy to access and more robust, and it's a
More
cost
robust,
saving.
we cannot say. If some company has invested a lot, made their on-premise robust, that can be on-premise, could be also robust.
It's kind of a virtual infrastructure which is available on demand and can be
Mhm.
accessed from anywhere, anytime, from any device.
Right, 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 right. Correct. Okay, I'll take my definition, the way I look at it. Okay, uh, and this definition I have taught to my nephew, who is studying class 6 also. Okay, the way I look at it. See, we have a data center, right? We have, if any big companies who are trying to deploy their massive applications, they need a data center. Our laptop could be a data center, could be a server also. If our laptop runs 24/7, it could be actually a small server. Whatever the configuration we have, 16 core, 8 core, some RAM we have, it could act as a server. But only one condition, it has to run 24/7. It has to be always connected to the internet and everything. But when we want to do massive scale, like Facebook, WhatsApp, right? They need a Netflix, Amazon.com. They need a massive platform to handle a workload. They cannot just set up the servers in one room, right? They need a bigger place. And that bigger place is what we call it data center. So friend, look at this data center. This is how it looks. a multi-story building in the outskirts of a city, multiple acres of land. Somebody who wants to set up this has to procure the land, construct the building, procure all the servers like this, friends, all the servers, storage, servers. Think about it. Netflix is using AWS, and just think about it, the Netflix content, how much content they have. They are leveraging AWS. So they need a massive scale. They cannot just buy one rack and get things going. No, if you're starting small, you can buy one rack, that's fine. Rack means this one rack I'm talking about. Okay, some 100 cores, 200 cores to be there in this rack. You can buy this rack, but when you need to massive scale, we need to set up a data center. So any company can set up a data center, right? When Amazon.com was, so when Jeff Bezos, right, we all know him, I'm owner of Amazon.com and AWS also. So he was setting up the data center for Amazon.com website, right? Amazon.com in early 2000, right? Late 90s, he was setting up this data center for Amazon.com. So this is what a data center looks like. Oracle has that, IBM has big players, Google has that, this, right? They have this from very long because they have massive scale. They cannot just have one room with servers and have that scalability done. No, not possible. So they need to have this kind of a data center. Now, whether you are on premise or cloud is just based on only one factor. Whether you own it or you don't own it. Ownership. If you own the data center, that's on premise. Simple. If you own it, if I am doing this, I am procuring the land, constructing the building, purchasing those servers, recruiting security personnel for the security of the facility, maintaining cooling mechanism, multi-billions of dollars investment. Okay, in setting up a data center, billions of dollars goes into that. When you own it, that's on premise. But when somebody else has set up like a business model and we leverage it, that's cloud. It's like having your own home versus living in a rented apartment. On premise is the ownership, right? But I don't have that billions of dollars investment. Most of people do not have. Big players have that. So what they do, but they have this business idea. They can recruit few developers, testers, QA engineers. They can build the application. Code can be developed, right? I can recruit 5 developers, 5 QA, 2 QA, and 1 DevOps engineer, and that's done. I can build my application, but I need infrastructure. So where do I go? I will use the cloud. They have set up everything, right? They have done the investment. AWS, friends, if I talk about AWS, similarly, you can explore all on other cloud also. If I talk about AWS, the global infrastructure, if I talk about it, they have 120 such data centers. They call it availability zones, AZs, grouped into 38 geographical regions. In India, they have 2 regions, in Mumbai and one in Hyderabad. In Mumbai also, they have 3 AZs. In Hyderabad also, they have 3 AZs. Look at the presence of their regions. Each region has multiple AZs. So they have set up this infrastructure. Why? Business model. They want to earn this. So when Jeff Bezos was setting up Amazon.com, he got this idea. Okay, why can't this hardware, right, that he was procuring, could be leveraged by others? And that's when this this AWS idea came to his mind. And he thought, okay, whatever the infrastructure that I am doing it, why can't it be leveraged by others? If others could leverage it can have a business model. And AWS was the first cloud provider. In 2007, this was launched. Azure, GCP launched much later, 5 years after. AWS, that's why AWS is so popular. It has the largest market share. 35 to 40% of market share is AWS. because they started early, 2007 itself. And this idea came when he was setting up on-premise for Amazon.com. This way he owns two big things, Amazon.com and in AWS. Right? So it's about the ownership. That's what I think. It's whether you own it, if you own it on-premise. If you don't own it, somebody else owns it, like AWS, Azure, like AWS, Microsoft, Google. If they own it, like a business model, you can leverage it. If I want, let's say I have my developers, I have my application developed, let's say. I recruit a few developers. I have my application. I want to deploy this. So what I should do? I don't need to call, okay, AWS call center, okay, I need some servers. No, they will not do it. They have a mechanism. They will tell you, sir, do one thing, create one account with us, AWS account with us, log in and do whatever you want. And we'll bill you. It's like shopping, right? So that's what they do. They just tell you, sir, create one AWS account. Whichever region, wherever you want to create infrastructure, select that region. I'm logging in, friends. So everybody, you all will be having this account. I'm going to guide you, friends. It's very easy, like how you sign up to your any social media platform. You can go ahead and create this account. So you log in and do your shopping work. Select where do you want to create the infrastructure. Okay, you want to create Mumbai. Okay, Hyderabad, Singapore, Tokyo, Frankfurt, London. Why would I select a region? That's the logic. Depending on the customer location, latency, and various factors, government regulations, we select a region and we go about creating infrastructure. If you want server, okay, I'll go with EC2. EC2 is a very popular service, Elastic Compute Cloud. You go here and get the server. How much of a server you want? Scale is enough. They have enough infrastructure. Get how much of a server you want. 100 servers, 32 core each. Get it. Pay. Monthly bill will come like a post-bill bill. Pay. If you don't pay the bill, can we stay in the rented flat if I don't pay the rent? No. Same thing. We are not ownership here. In the cloud, we don't own it. We just pay for what we use. Like how we stay in a rented apartment. We don't own the home, but as long as we pay the rent, we can enjoy the services. That is what the cloud is. Use whatever you want, get your shopping done. You need storage, servers, get it, whatever you want, you have the way. And that's what when you say, do you know cloud? That's what we need to know, how to use this, how to get the server, storage, load balancer, databases. And there are so many services they are coming up with, AI, ML, game development, internet thing, machine learning. They have so many services. They are making things simple and simple. They have automated the simple. They are making automation. So cloud is going to be always there. They will make things simple. AI is making things simple. If they integrate with cloud, they will make it even simpler. If you go machine learning, we have models which can do a lot of things. Use Bedrock. They are making making it automated. You can use any of the model to develop any of the AI. They have so many models here. So you can use any of the model and create machine learning algorithm on top of it. They have so many models here. You can use any of the models. So cloud, AI is making things simple. Understand cloud. AI is making things simple. Cloud is making it even simpler to automate it. So cloud, we have to know everybody, and it's always going to be here. Okay, it's always going to be here. Because they are adding it as per the technologies are evolving. Kubernetes was not there 10 years back. 2007, Kubernetes was not there. But in 2015, Google launched Kubernetes. They've integrated Kubernetes. They have EKS service now. They have EKS service. Get EKS service. You create a Kubernetes cluster, deploy your application. So cloud is always going to be here, friends, and we all need to know cloud. Okay, if you're not in a setup where you're not learning cloud, find a way to learn cloud. Because that's very important. If not, you would not be able to switch. Let's say you go for the interview and if you say, I don't know cloud, I have not worked. Oh no, who cares, right? In the interviewer would not care. He will look for the next person. Because if their incomplete infrastructure is in cloud, and if you say you don't know cloud, then why they will recruit you, right? Simple process. So that's how important it is. Okay. So friends, again, I'll go back to my definition part. One is called data center. It's all about whether you own data center or you leverage it. Okay, friends, from the understanding perspective, are we clear on what is cloud? Absolutely clear. Can I get a thumbs up from all of you? Okay. Any questions? Okay. Friends, now how do we get cloud? Okay, friends. So friends, this is going to be the last session. So I would like those who are getting enrolled, not getting enrolled, doesn't matter. Friends, go to this website and create an account for you. Go to this aws.amazon.com. Go to this website, simple, amazon.com, go to aws.amazon.com and create an account, free account, cloud account, sign up, use your Gmail address, sign up. They will ask your details like PAN card, provide them. They will ask your banking details. They can ask your debit card, credit card details. They will not detect the amount. I can vouch for it because they have not detected amount for me anytime. They never do auto deduction. I have been getting bills, but if I show you, I have bills, but they have never deducted auto deducted amount. One of the good things about AWS I like that if you don't pay the bill, they have your details, but they will not auto deduct the amount. If you don't pay the bill, look at my 1 month is pending. I need to make the payment. Because I have been using this account, I'm not part of free tier, so I get charged because I use a lot of explore things. Look at this, I am yet to pay this amount, right? And they're not auto deducting this amount. I have to make the payment. If I don't auto deduct for 2 months, if I don't pay the amount, let's say September, October, if I don't pay, they will suspend. I would not be able to log in. That's what they do. They will not auto deduct the amount. And you get the bills in detail. Like how do you get postpaid connection? Like if you have a postpaid phone, you get the details, right? Where do you spend, where did you discuss every detail they will have in the cost explorer. They will have every details, right? In the cost explorer, where did you spend, right? Every detail, which service did you use, right? So go to aws.amazon.com and sign up and create the account. Verify your details, debit, credit card details. They will detect INR2. If you're using Indian card, $1 for international card, they deduct. They also refund you, right? And you would be able to log in the way I showed you. Once you sign up, use free tier, select free tier, personal use, don't select business use and all. Personal use, learning purpose, student, just use the normal stuff and create the account, right? And you'll be able to log in like this, friends, right? And we'll take it from there. Okay, so when we meet next on Monday, friends, I'm going to talk more about it. I'm going to talk about EC2. I'm going to create a server so that you can practice Linux, right? So please take a call, friends, and we will meet on Monday, right? And we'll discuss further. Any questions? Last question, I can take it up for you today. Okay. Sounds good. Thank you so much, everybody. We'll meet on Monday. Thank you.